So, you've probably heard the term GIS, right? Geographic Information Systems. It's the tech that powers the maps on your phone, helps plan city infrastructure, all that stuff. But there's this other more intense side to it called Geospatial Intelligence, or GEOINT. Think of GIS as the powerful engine, and GEOINT as one of its highest performance applications. It's all about taking that location data, satellite images, drone footage, sensor data, and analyzing it to understand what's happening on the ground, especially in situations where the stakes are incredibly high. It's not just about making a map, it's about making a map that tells a story and gives you actionable intelligence. Essentially, GEOINT is the art and science of turning raw geographic data into critical insights. It's the why behind the where. While a standard GIS map might show you the layout of a city, a GEOINT analysis will tell you which roads are most vulnerable, where populations are moving after a natural disaster, or how a landscape is changing over time due to climate change or conflict. It's a field that combines geography, data science, and some seriously advanced technology to provide a level of understanding that was basically science fiction just a few decades ago. And that's what we're diving into today. This isn't just theory. GEOINT is being used right now in some pretty mind-blowing ways. We're going to break down 4 key real-world applications that really showcase its power. We'll look at everything from military defense and tracking changes in conflict zones, all the way to predictive policing and crime mapping. It's a deep dive into how understanding where is changing how we see the world. So, let's get into it. Alright, so first up, let's talk about defense and military operations. This is probably one of the oldest and most advanced applications of GEOINT. Before a single soldier sets foot on the ground, GIS is already hard at work, building a complete multi-layered picture of the operational area. We're talking about creating incredibly detailed 3-dimensional models of the terrain. This isn't just a flat map. It's a virtual sandbox where commanders can see every hill, every valley, every potential ambush point. This kind of terrain analysis is mission critical. It helps determine the safest routes for convoys, identifies the best high ground positions for observation posts, and even predicts where the enemy might be hiding. By layering data, elevation, vegetation cover, soil type, lines of sight, GIS can run simulations to find the most optimal paths, minimizing risk and maximizing efficiency. It's about removing the guesswork from incredibly dangerous situations. Then there's the process of selecting locations for military bases or forward operating posts. It's a massive logistical puzzle. You need access to water, defensible positions, stable ground for construction, and clear lines of communication. GIS helps analyze all these variables simultaneously. It can process huge data sets to flag ideal locations that meet a dozen different criteria, something that would take weeks or months to do with traditional reconnaissance. But where it gets really futuristic is the integration of live surveillance. Modern command centers look like something out of a movie, with massive screens displaying real-time data feeds. GIS is the software that brings it all together. It can take a live video feed from a drone, overlay it directly onto a 3-dimensional map, and track friendly and enemy units in real time. This creates what they call a common operational picture. So everyone, from the general in the command center to the squad leader on the ground, is looking at the same, constantly updated map. They see the drone's view, they see intelligence reports pop up as geotagged icons, and they see the location of their own forces. This level of synchronized information and spatial awareness is a massive tactical advantage, and it's all powered by the quiet, powerful engine of GIS working behind the scenes. Now let's move from planning operations to understanding their impact. One of the most powerful and frankly sobering uses of GIS in GEOINT is change detection, especially in conflict zones. When access on the ground is impossible or extremely dangerous, satellites and drones become our eyes in the sky. And GIS is the tool that helps us make sense of the millions of pixels they capture, telling a story of what's changed over time. The core idea here is pretty straightforward, but technologically complex. You take 2 or more images of the same location, captured at different times, say, one from before a conflict and one from a few months into it. By feeding these images into a GIS platform, specialized algorithms can automatically compare them pixel by pixel. The software is trained to ignore minor changes, like different lighting or seasons, and highlight significant man-made alterations. What does that look like in practice? It means being able to systematically and accurately identify destroyed infrastructure. The GIS can automatically flag every building that has been damaged or completely leveled, creating a precise map of destruction. This isn't just for historical record. Humanitarian organizations use these maps to prioritize aid, estimate the number of people who have lost their homes, and plan for reconstruction efforts long before they can safely get teams on the ground. This same technique is crucial for tracking population displacement. By analyzing satellite imagery, analysts can spot the sudden appearance of massive refugee camps or informal settlements near borders. They can monitor the growth of these camps over time, which gives aid agencies a better estimate of the number of people in need of food, water, and shelter. It provides hard data to back up anecdotal reports, which is vital for allocating resources effectively. And finally, it's used to uncover illegal activities that thrive in the chaos of conflict. Think illegal mining, logging, or the construction of unauthorized checkpoints. These activities leave a visible footprint on the landscape. By comparing new imagery to historical archives, GIS can pinpoint the exact locations of these new scars on the Earth. This intelligence can be used by international bodies to hold perpetrators accountable and to understand the hidden economies that often fuel these conflicts. So, we've talked about static analysis, mapping terrain, and detecting changes over time. But what about tracking things that move? This is where GEOINT gets into real-time, high-stakes territory, and it's where GIS, combined with high-resolution imagery and AI, really starts to feel like something from a spy thriller. The goal is to create a persistent, dynamic view of activity on the ground. It all starts with the imagery. We're talking incredibly high-resolution satellite photos that can distinguish individual vehicles, or even groups of people, from hundreds of miles up. Then you have drones, which can provide continuous, low-altitude video over a specific area for hours at a time. But just having the footage isn't enough. No human could possibly watch all of it and make sense of it in real time. That's where the AI comes in. GIS platforms are now equipped with powerful machine learning models. These models are trained to recognize specific objects within an image or video feed. They can be taught to identify a certain type of tank, a supply truck, or a missile launcher. As the satellite or drone captures new data, the AI automatically scans it, identifies these objects of interest, and tags them with their precise geographic coordinates on the map. This creates a live, evolving picture of enemy movements. Instead of just knowing that a convoy left a base, analysts can now track its exact route, its speed, and its destination. They can see if it deviates from an expected path or if it stops in a suspicious location. This level of detail allows for predictive analysis. If a certain number of artillery units are seen moving towards a specific sector, commanders can anticipate an attack and move to reinforce that area. This isn't just limited to military hardware either. The same technology is used for border security and monitoring. Drones can patrol vast remote stretches of a border, and the AI-powered GIS can automatically flag any unusual activity, vehicles crossing at unofficial points, or large groups of people moving through a remote area. It provides an early warning system that allows authorities to respond quickly, turning a massive, unmanageable area into a monitored, understood space. Okay, for our last application, let's bring it back from the battlefield to our own cities. GEOINT and GIS aren't just for international conflicts. They are fundamentally changing law enforcement and public safety through crime mapping and what's known as predictive policing. The core idea is that crime isn't random. It follows patterns, and those patterns are almost always tied to geography. At its most basic level, crime mapping is exactly what it sounds like. Law enforcement agencies take all their incident reports, thefts, assaults, burglaries, and plot them on a map using GIS. Each point on the map represents a crime and contains data, what happened, when it happened, and where it happened. Immediately, you start to see things you couldn't see in a spreadsheet. Clusters of incidents or hotspots become instantly visible. This allows police departments to be much smarter about how they allocate their limited resources. Instead of just random patrols, they can direct officers to be more present in these high-crime areas at specific times of the day or week, when incidents are most likely to occur. This data-driven approach means they can be more effective at deterring crime simply by being in the right place at the right time. But it goes deeper than just plotting dots on a map. GIS allows analysts to layer other datasets on top of the crime data to look for correlations. For example, they can overlay the locations of bars, bus stops, schools, or parks. They might find that a spike in robberies is happening near ATM machines on Friday nights, or that car break-ins are concentrated in poorly lit parking lots. This analysis helps them understand the behind the hotspots. And this leads to the most advanced and also most controversial application: predictive policing. By feeding all this historical crime data, along with other variables like weather, paydays, and local events, into a machine learning model, the GIS can generate a forecast. It creates a map that shows the probability of specific crimes occurring in different parts of the city over the next 12 or 24 hours. This is meant to help police get ahead of crime before it even happens, but it also raises some serious questions about bias in the data and the potential for over-policing certain communities, which is a whole other important conversation. So, there you have it. 4 really different but equally powerful examples of geospatial intelligence in action. We saw how it creates a digital twin of the battlefield for military defense, giving commanders an unprecedented view of the terrain. We looked at how change detection with satellites can bear witness to the impact of conflict and guide humanitarian aid. Then we dove into the high-tech world of tracking moving targets with AI and drones, turning raw footage into actionable intelligence. And finally, we brought it home to see how those same principles help law enforcement map crime and even attempt to predict it. What connects all of these is the fundamental power of GIS. It's the underlying platform that makes GEOINT possible. It's the tool that takes abstract data points, satellite pixels, and reports, and weaves them together into a coherent visual story. In the modern world, where we are drowning in data, the ability to see that data spatially is more than just a neat feature. It's a critical capability. It's what transforms information into intelligence. From national security to community safety, the applications are just getting more advanced. The maps are getting smarter, the analysis is getting faster, and the impact is growing every day. It really shows that understanding where things happen is often the key to understanding everything else. I'm curious though, which one of these applications was the most surprising or interesting to you? Was it the military stuff, the crime mapping, or something else? Let me know down in the comments below. Peace.